Okay, so good morning to everyone in the meeting. My name is Suhas, and my team members are Noorine, Sanjay, and Vinay. And our title of our project is Recommendation System for Streaming Data Using AI. So I'm having a bit of an issue with my screen recorder, so I can't switch tabs. So I just pause the video here and I'll resume from there. Okay, so this is our code. So okay, before I just explain the code, I'll just give a small quick idea on why we are doing this or why we got this idea. So we all know that in multimedia today, we don't search for the content we want to watch anymore, or we don't think about it much. For example, you take Netflix or YouTube or anything in music, people don't even think about what they want to watch today, or when they take their phone, they have no thought in. They just know the content is going to be recommended to them on their screen, and it goes in that way. So even Netflix, you can see many people they don't even search for. No one uses the search bar anymore. It's always like, okay, I know something is gonna pop up and I'll watch it. So that kind of intrigued us. We wanted to do something related to that. So that's why we're doing this recommendation project. Before the code, I'll just show you the dataset we worked on. So this is our movie dataset. It contains around 1 lakh data points, and this one contains all the movie info like the name, genre, and movie ID. And this one contains the user info like the user ID and the ratings which he or she has given to X movie. Okay, let's go to the code. So this is where we are using obviously Python for this because it's related to data and stuff. So yeah, here we have imported all the environments and created the environment for doing this project. For deep visualizations, we have used Matplotlib. For deep learning, we have used the Keras API. Then yeah, we have used in NumPy and Pandas for data analysis. So if we go further, first we did the data pre-processing steps. So we extracted the data from the data Excel sheet and we stored it in this data frame. And if we keep going, yeah, we just did a little summary of it, like it contains 1 lakh data points, the mean, max, min, all that stuff. Then we dropped irrelevant columns. We don't need the timestamp column, so we dropped it. And after that, if we go more further, okay, so yeah, then we handled missing values. There were a few missing values, so we had to handle those. What we did to handle them is we first found the missing values in each row, and then we filled the missing cells with the mean values of the neighboring datasets. So like in a row, let's say some column has a missing value, we'll just fill it with the mean value of that column itself. So it will not be like an outlier. It will be in the same same path, I would say. Then we went a little bit through visualizations and stuff. We saw how many genres this dataset has. So you can see there's a lot here. Then yeah, a little bit of workload and all that stuff. Then yeah, here's the mean ratings and total ratings for each movie. You can see this movie has the highest number of ratings. And yeah, we plotted some graphs to see which movie has the highest rating and all that stuff. So yeah, that's irrelevant to the main algorithm. Just to when we got the dataset, we wanted to learn about the data. So that's why we went through this process. Okay, so now coming to our algorithm, the main intuition behind the project is based on an algorithm called collaborative filtering. So this algorithm, could say the idea behind it is there's two types in this also. There's user based and item based. We go and how the both of them works is that let's say in user based, we find two users who are similar or who have similar taste in music, and so if we find a pair of users like that, we'll take one user and we'll see what movies they are watching or rating. And if we see that user is rating some movies with a good rating, meaning that user likes it now, so we'll recommend those movies to the other user who are in the same pair because they have same taste. So obviously they gonna like the same set of movies. So if one user watches or likes this, we'll recommend those movies to the other user. Same logic is in item based also. So in item based also we'll find two items which are similar and we'll recommend those similar items to the similar users. So in our project we are doing item based. I mean user based. I'm sorry. We have our intuition is user based. So here you can see we have plotted a utility matrix. This is what we use to find the similarity between users. To find similar users, we put up this matrix, and we've calculated a value called Pearson's correlation coefficient. So let's say you have two variables. To find the relationship between these two variables, we calculate the Pearson coefficient between them, and we get a value between -1 to +1. So if it's -1, obviously they are users of dissimilar taste. They are not similar at all. So you could say they are not similar and you can ignore them. But if there's two users who have a closer value to +1 Pearson value, you could say they are similar. So you could consider them as a pair itself. So that is why we are calculating Pearson's coefficient here. So if we come here, see in our user utility matrix, I've calculated the correlation, and you can see these values. So if user 1 is obviously similar to user 1, that's obvious. So 1 and 2, this is the value, and so on. We have calculated for everyone. Okay, you can see the time is more than 5 minutes. I'll just go a bit more fast. Yeah, so that's where we calculate Pearson's coefficient and all that stuff. Now to implement our collaborative filtering, we have used deep learning methods. So we'll directly go to that. like that. And I've already told you guys that you're using Keras API for this one. So yeah, so here it is. So yeah, first I'll convert in this model. I've converted the categorical variables into numerical values, because for machine learning algorithms you need numerical values for better results. Here I've used that using the pandas AS type function. Then I would use the train test split also. I would divide them into like 80% training and 20% testing. So after that, then I've used select KBase for feature selection. In this case, it's obviously ratings, because I already said that's the data point we are giving importance to find similar users. Then let's come to the model building stage. So you can see here in the input layer, we'll take the input layer and we'll flatten it. And after flattening it, we'll concatenate them to find similar categories and put them into one-dimensional arrays. So first they'll embed the layers. After embedding, they'll be in multi-dimensional layers while embedding. We want them in single dimension so that we can find all the common categories. That's why we'll first flatten and concatenate them. And then after that, we'll train a model obviously. So for the model object, we'll do the dot fit function. And after training, I'll give a batch size of 64 with 10 epochs. And the metrics we have used here to find the performance of a model is called MSE, mean squared error. Now mean squared error is the difference between the original ratings and the predicted ratings. So as you can see here in this first model, we've got a mean squared error of 0.843, this big value here. So what I did, I thought, okay, so we've got this much value for this model. Let me try one or two more variations of this models and see if I can get better results. So in my second model, it is similar to the first one, except I have applied some regularizations in my second model. So if this is my second model here, you can see it's all same as the first model. And the second model, I've used the dropout regularization. Now why I'm doing this is because regularization helps us to prevent overfitting. Overfitting means that an algorithm or a model, if it gets too complex or too it learns a lot from the single data set, then it will become too much. It can't generalize stuff. It can't, if you see some new data, it can't predict well, because it's totally used to the data set which we have provided. So to make sure it generalizes and doesn't overfit the data set, we use regularization techniques. So that is what I've done here. What dropout does here is, you can see dropout 0.5 output. So that means that any input has a 50% chance of being dropped to 0. So when we do this we can say that we are making sure it's going to generalize well. So that for this model also, when I did found the MSE, I got a value of 0.7870. You can see it's less than the previous model, which is good, because we want the lesser the MSE, the better the accuracy we have. So yeah, now second model we got this, and one more variation I tried. What I did was I added a little bit more dense layers. Dense layers means the embedding layers in between the input and output layer. I added a little more dense layers, and in this model, yeah, this other model, and I got a MSE of 0.87, which is more than our first model itself. So it's not a better result, but it's a result nonetheless. Then I just compared all these three models with their performance and plotted some graphs to show you guys. So you can see here our regularized model has the best. MSE wise, it's the best, because it has the lowest value, which is what we want for a model. And then here is the trailing and validation loss comparison. It's almost similar for three graphs. Then coming to the training time. So our basic model took the most time. It took more than 175 seconds. Regularized model in second and modified in third. So modified takes lesser time to train, but regularized model in conclusion gives us the better result. And just to show you this guy, we've also created a small user interface. So I'll just show you after this coding thing. So I'll just pause it here. So here's the user interface that we've created to show our model and how it's working and all. I've already shown you from the previous coding section that our regularized model gives us the best results. So that's the model which is behind this interface. Okay, so it'll ask us a user ID and movie name. You have to make sure that this whatever data it's asking, it should be asked from the dataset itself, because the model, it has learned from that dataset. So in a real world scenario, Netflix and all that stuff, they have a continuous flow of data of the users, so it can keep on updating. Here, since for this project we use a dataset, so only from that part I can give the input. So okay, let's say user ID of 100th user, and a movie. What more will you give? Avengers. And now we're not sure if this 100th user has watched this movie or not, but the model can predict anyways, because it has learned from that data set. So if I click on get recommendation, it will give us 3.421, which is more, and this is given on a scale of 1 to 5. So the user mostly like it is above average rating, so the user will mostly like this. And let's go and give another try. Let's give user 234, and okay, let's give this movie Sabrina, and if I click on recommendation, user gives a rating of 2.9. Now that is not a big rating, I would say. It is okay, neutral wise. So that's why we even put a label. So yeah, so that you can see that our model can predict the ratings the user would give. And I've definitely gone more than the exceeded time. The thing I'm recording and expecting so much is that maybe right now I could not make it to this meeting because I have an interview today. So this recording is being done the previous day on a Sunday. So that's why I'm trying to cover everything I can in this. Whatever is being explained in the PPT, I'm trying to make sure it's come in this video, so everyone in this meeting, the judges and all my team members can see this. So yep, that is pretty much all there is in our project, and I hope you guys liked it. So thank you.